Proxima Centauri and the discovery of Proxima B. Proxima Centauri, the closest star beyond our Sun, is more than just another speck of light in the galaxy. It is a cosmic neighbor that has captured the imagination of scientists for over a century. This faint red dwarf star was first identified in 1915 by the Scottish astronomer Robert Innes, who recognized its proximity to the Alpha Centauri system. Together with Alpha Centauri A and Alpha Centauri B, it forms a stellar family that is both scientifically rich and endlessly fascinating. Although Proxima Centauri lies just 4.24 light-years from Earth, an incredibly short distance on the scale of the Milky Way, its glow is so faint that it cannot be spotted with the unaided eye. For centuries, it remained invisible to human stargazers, a hidden neighbor quietly burning in the night. Its modest size, its cool temperature, and its long lifespan make it an unassuming star, yet one of profound importance to the search for life. Unlike our Sun, which will shine for about 10 billion years in total, red dwarfs like Proxima Centauri can survive for trillions of years. They burn slowly, gently, and with extraordinary endurance, outlasting most other stars in the galaxy. But their faintness comes at a cost. The regions where planets might sustain liquid water are drawn in extremely close to the star itself. This region is known as the habitable zone, and in Proxima's case, it stretches from only about 0.05 to 0.5 astronomical units. To put this into perspective, Earth orbits the Sun at 1 astronomical unit, so Proxima B, if it is to be habitable, must orbit far closer to its star than Earth does to ours. Proxima Centauri's scientific importance grew dramatically when astronomers discovered Proxima B, an exoplanet orbiting within this habitable zone. Proxima B is roughly the same size as Earth, with a mass of about 1.17 Earths, making it one of the most Earth-like exoplanets ever found. The possibility that liquid water could exist on its surface instantly made it a leading candidate in the search for alien life. Yet this opportunity comes with extraordinary challenges. Proxima Centauri, despite its small size, is an active and temperamental star. It frequently erupts with stellar flares, bursts of powerful X-rays, and streams of ultraviolet radiation. These outbursts are far stronger and more frequent than those of our own Sun. For a planet orbiting so close, the consequences can be devastating. Its atmosphere could be stripped away, leaving a barren surface exposed to harsh space weather. Despite these risks, the discovery of Proxima B was nothing short of a scientific milestone. In 2016, astronomers using the European Southern Observatory confirmed its existence through the radial velocity method. This technique involves watching for subtle shifts in the star's motion, tiny wobbles caused by the gravitational tug of an orbiting planet. From these delicate oscillations, scientists inferred the presence of a world orbiting every 11 Earth days around Proxima Centauri. That world was Proxima B, a rocky planet locked in a close dance with its star. The significance was enormous. For the first time, an Earth-sized world in the habitable zone of our nearest stellar neighbor had been confirmed. Proxima B was no longer a distant dream or a mathematical possibility, it was real. And with its discovery, humanity suddenly had a prime target for future studies in the quest to find life beyond Earth. Ground-based telescopes provided the first glimpse into this world's nature. But even the most advanced observatories on Earth face limitations. Our atmosphere bends and scatters light, introducing distortions that blur fine details. Light pollution from human civilization further complicates the work, masking faint signals that could reveal critical truths about distant planets. To truly unlock the secrets of Proxima B, astronomers realized they needed a more powerful tool, one that could rise above Earth's atmosphere and see with unmatched clarity. That tool would become the James Webb Space Telescope, a technological marvel designed not just to extend astronomy but to revolutionize it. James Webb Space Telescope and the promise of Proxima B. Unlike the Hubble Space Telescope, which focused mainly on visible and ultraviolet light, JWST was built to see the universe in infrared wavelengths. This unique ability allows it to cut through thick clouds of cosmic dust and reveal objects hidden from Hubble's view. Its massive 6.5-meter primary mirror, more than twice the size of Hubble's, can gather immense amounts of light, detecting the faintest and most distant signals in the cosmos. JWST's design is unlike any telescope before it. Its gold-coated mirror segments are arranged in a precise hexagonal pattern, reflecting infrared light with unmatched efficiency. A tennis court-sized sunshield protects its instruments, cooling them to an astonishing 233 degrees Celsius, preventing the telescope's own heat from interfering with its vision. Positioned at the second Lagrange point, about 1.5 million kilometers from Earth, JWST avoids our planet's glow and interference, offering an uninterrupted window into the universe. With its advanced instruments, NIR-CAM, MIRI, and NIR-SPEC, JWST is not just a telescope but a scientific powerhouse. It can analyze the atmospheres of exoplanets, searching for key molecules such as water vapor, methane, and carbon dioxide. Detecting these biosignature gases in Proxima B's atmosphere would be a breakthrough, bringing us closer to answering the age-old question: are we alone? Yet Proxima B is no Earth twin. Because it is tidally locked, one hemisphere faces perpetual daylight while the other remains in endless night. This creates extreme contrasts, scorching heat on one side, freezing cold on the other. But along the twilight boundary, known as the terminator zone, conditions may be moderate enough to allow liquid water, and possibly even life, to persist. Still, the dangers are immense. Proxima Centauri's constant flaring may erode the planet's atmosphere over time. If Proxima B lacks a protective magnetic field, its surface could be exposed to deadly radiation. Yet Earth has shown us that life can endure in the harshest conditions. Microbes on our planet thrive in volcanic vents, acidic lakes, and even radioactive environments. Perhaps Proxima B harbors life in hidden refuges. Subsurface reservoirs, underground caves, or deep aquifers may shield organisms from the violence of their star. If so, they might resemble Earth's extremophiles, adapted to survive in places where humans cannot. Investigating Proxima B is not just a scientific pursuit, it is a philosophical one. To discover life there, even in its simplest form, would transform humanity's understanding of itself and its place in the cosmos. And even if Proxima B proves lifeless, it still broadens our knowledge of what makes a world habitable. Other exoplanets, discovered by missions such as TESS, continue to remind us that our galaxy may be filled with Earth-like candidates. The search for life on Proxima B is only the beginning. Future technologies may one day send probes across interstellar space, echoing the spirit of today's Mars rovers or Europa missions. For now, telescopes like JWST act as our eyes, bringing distant worlds into view. Ultimately, Proxima B is more than just a rocky exoplanet orbiting a dim red dwarf. It represents humanity's restless curiosity, our determination to explore, and our longing to understand whether we are truly alone in the universe. Each discovery, each glimpse into its mysteries, pushes us closer to solving one of the greatest riddles of existence. What was once the realm of imagination and science fiction, journeys to distant stars, is slowly transforming into our next great reality.